Hi everyone. In this assignment, we will be evaluating the RAG that we built over the last assignment, which is our movies. Our movies RAG retrieves the information about movies based on the user question and provides the recommendations. So I'll just go through the how to evaluate this particular movies RAG or else any RAG. Basically, this methodology that we have used in this evaluation can be extended to any RAG basically. So I'll just go through some of the metrics that can be used to evaluate this. Um, I'll go through one by one. Uh, so first one is the context precision. To do all this, we have basically prepared two datasets manually for evaluating the retrieval side. So one of the data set that I have prepared is basically this one. So when was the Godfather movie released, for example? So I know the query now, and I know the context uh, which was uploaded to the Pinecone in the previous assignment. So based on that, I have created the dataset manually with over 30 to 40, with over more than 30 to 40 movies per single set and there is one more data set which we evaluate. This is movie recommendations. Here for a single query we'll be having multiple contexts in place that can be possible in the output. For example, can we recommend classic sci-fi movies? If I ask this question, there could be some possible five movies, up to five movies that are possible. So based on this, we are uh, evaluating the output of RAG that we are getting that we are getting when we input the query. So we'll go through them. Initially, I loaded the test dataset, which I created. For that, I have written some function, and then get RAG context is something I am calling my backend, RAG backend, which we created over the last assignment, and then it gives me the context which is in the movie's description column. So yep, and the next calculate context precision is the first metric where it will retrieve the entities and and find how many of them are relevant, and based on those intersection will calculate this. So it's just precision like true positive by true positive plus false positive, which is the precision formula in general. So out of the predicted variables, how many are the actual positive? That's what we measure in the precision. It's the same thing that we are doing here as well. Um, and similarly, recall out of the all available positive values, how many of the positive values our system is predicting. That's what recall is basically, and we are applying the same thing here to measure the context recall and how many of them are retrieved and relevant, and then measuring the intersection with uh, with this recall formula here. So we our system scored around 72% for the precision and 61% for the recall, which is not bad, I would say. And yeah, let's see how other metrics will perform. And context relevance is something we use cosine similarity and TF-IDF factorization to compare the query and retrieved context, how much they are relevant based on similarity. That's also a good metric, and it are scored high, very high similar because we are using kind of cosine similarity to retrieve them, a kind of similarity method already to find the best possible things, and it could be obviously matching to the query. So that could be the reason that we are getting very good relevance here. Yeah. And next one is context entity recall. We are using uh, it compares basically retrieved context with the entities from both query and relevant context. So common entities divided by total number of entities in query and relevant context, and that's what make the context entity recall. So we got around 65% for this context entity recall. That measures that's actually a decent thing. So showing that the system captures good portion of important entities for the given query, and that's nice actually. So and then moving on to the noise robustness test, where we create the faulty names for the metrics that we have discussed till now. We are using same two different data sets to calculate them and taken the average and displayed over there. But yeah, for noise robustness, created different data set where we manually manipulated the names. For example, here we have purposefully kept the inception name wrong and see if our system could be able to recognize it or not. And to be like our system can only recognize 53% of the queries that it has received, and it's a room there is room for improvement, I believe, in this area where we can tune the prompt and get the things done very efficiently. We'll go through the process of the improvement, how I improved the prompt and other techniques over the after seeing the generation metrics as well. So yeah, the generation metrics, these are some standard metrics like faithfulness, answer relevance, information integration, counterfactual robustness, and negative rejection. So I have created a data set for that as well. So what is the query and what is the type that we are measuring? Is it a standard, counterfactual, negative, faithfulness, and other stuff? And I have created the ground truth as well, based on the context I'm having in place. So everywhere I measure the BLU score in faithfulness and between the generated response and ground truth and see how much it is matching. And answer relevance is also using similarity, cosine similarity between the query and response, and which is equivalent to what that we have seen earlier in context, but this time it is a for generation, so it's little different. But using the cosine similarity, that's what's best metric I believe to measure the relevancy. And next, information integration, where we got around 62%, which is a decent integration. This is also a similarity between response and the ground truth that we are having, how closely the ground truth matches the response. It could be even it was low. I believe it is making decent performance. Our drag is doing very decent performance, I believe, because sometimes even with the low cosine similarity, the actual meaning does make very similar to the ground truth uh, after doing some manual evaluation, I believe. But yep, moving on, counterfactual robustness is where we generate hypothetical queries and see how our system is evaluating between the movie characters not going outside, which will be negative or noise. That is obviously our system is doing good. So 72% of the case our counterfactual queries got good answers, and yeah, we are evaluating it with the ground truth against, so it makes 72% of performance. And next, negative rejection, where we generate inappropriate queries asking political or any non-related movie queries to the RAG and see if it could be able to say, I don't know, or this is outside of my expertise kind of response. And only 60% of the cases our RAG system denied to respond those queries, but most of the time, like remaining 40% of the time, it answered those non-movie related queries. So we can improve that with the prompt engineering that we have learned over the course. So yeah, I have curated the results over this table that we have seen, like metrics, context precision, recall relevance, and robustness scores as well. Uh, th- these are the different scores with a single source of truth in the context where the query is related to one particular movie, and where the queries can give multiple recommendations. Like when we ask our RAG recommend sci-fi movies, in that case we'll be getting multiple answers. So after curating multiple possible contexts, how many of them are actually matching and such stuff. So we evaluated that over here as well and got around these scores. Uh, and yep, and then metric results, generation metric results that we have seen also been placed in this table. Next, latency for each query to get the response that includes query standalone query creation, fetch context, and generate answer. Total it took around 6 seconds because we are calling the LLM twice here. So for generating the back and forth query creation and answer creation, it is taking around 6 seconds, out of which 4 seconds is basically for 4 to 5 seconds is basically for the LLM response inference creation as well. Yep. And let's see how we can improve the couple of metrics that we have that where our RAG doesn't perform really well. One of them I felt is noise robustness, which is very low, which can be easily improved with the help of prompt engineering, along with the negative rejection, which is also significantly low. These two techniques can be very easily improved with the prompt engineering that we have learned. So query after getting the query from the user, while creating the standalone query, we are using this kind of prompt initially, but when I change the prompt to very detailed in a detailed way, giving instructions and such stuff, like I'm clearly mentioning, if you are unsure about the correction, keep the original spelling, but if not, please try to correct the misspellings. So when we give this particular detail, our noise robustness score increased to 96%, which is very significantly high, uh, which is very good because the simple prompt engineering technique that we learned is used to increase the score from 53 to 96%, which can able to recognize the most of movie names because it already been pre-trained over the movie data set, I believe. So it is able to identify most of the spellings that got wrong of movies basically here. And then the other one is negative rejection, which you got only 60% initially, but after giving the more detail, like this is very simple detail that we mentioned initially to reject them, but I've improved that statement to little more rich, basically asking user if the movie is not known or if it is not related to movie, get some movie identified from the query. This is kind of movie classification thing, zero shot prompt engineering technique, which can be used to reject the queries which are not related to movie. Yep. This approach increased performance. We initially got 60%, it got increased to 87%, which is also very. The other technique that could improve the performance of system is context ranking. Uh, the answer in context doesn't always stay in the top of the context. It can stay in lower part of the context as well because we are retrieving top three or top five documents from the vector DB, and we are combining them and sending them as a context. So our answer can be the third or fifth document as well. It always not necessary to be the first one. Since the attention mechanism doesn't uniformly give attention to all the parts of context, this context re-ranking does really help improving the performance of our system. Um, we are now using the pre-trained LLM, which basically takes a group of documents and the query and re-ranks them according to the query. Now we are using Cohere, um, which does provide different re-ranking LLMs as an API service, mm, which is freely available. So I'm using them to re-rank my context, the documents that I'm retrieving from the vector DB, and generating the answer based on that. This really helps the solve the problem with respect to Titanic that I'm having, and also many other movies like Titanic, which is having a similar movie. For example, Toy Story and Toy Story 2 is also another example. If I ask question about Toy Story 2, it might pick Toy Story or the vice versa. But these kind of problems can be solved with the help of context ranking. Yeah, these are the some techniques and evaluation metrics that can be applied to any RAG in general. Thank you.